So your team describes you guys as we are the Shopify of AI.
Initially, it was just getting people GPUs access, right? And then it kind of evolved into something that's more profound. People don't just need the GPUs access, but also the entire ML stack. They just want to have a simple API for them to play with.
Yeah, I mean, it's like that old saying, the future's already here. It's just unevenly distributed.
AI is the gift that keeps on giving, and we are just getting started. Thank you for tuning in to another What the Future podcast. Today, we have Alex Yeh, CEO and founder of GMI Cloud. Now, GMI Cloud describes themselves as the Shopify of AI. If you don't completely understand what that is, stay tuned and Alex will explain. But in the meantime, what I took away from this podcast was the complexity of the entire AI stack. It's not just the hardware, it's also the software, but it's also the people and the intelligence that we need to make the entire stack run. We go to ChatGPT, we press a button, and we get these results. But what's going on behind the scenes is absolutely complicated and exciting. And that is what we dig into today. Thank you for tuning in. Hope you enjoy the show. We got to change the game. One of the biggest challenges with AI is access to GPUs, and not just the GPUs, but the entire stack, so you can actually do smart stuff with your GPUs. So today, it's an honor to have Alex Yeh, the CEO and founder of GMI Cloud. They're disrupting that space of GPU data centers. Thank you so much, Alex, for joining us today.
Thank you for having me.
You know, Alex, the first time Chris and I talked to you, I have to say, that was a fun conversation. And I wish I wish it didn't end, but I know that you had to leave us. But this conversation around GPU data centers is just so fun. It's a huge market. You guys are doing some great things. Can you tell me a little bit? Can you tell us again how did Alex get here? Can you tell us a little bit from the beginning to what brought you here today?
Yeah. So I guess I have to start with GMI's name. It stands for General Machine Intelligence Cloud, so it has that IBM vibe.
Okay.
Or kind of people call us the gonna make it cloud. Yeah. So I started this in about 2019 when I dabbled into kind of the entrepreneurship process. So I graduated from Hopkins with a materials engineering degree, and then I later become one of the youngest partner of Headline Crypto, which is Headline is a SF based venture capital firm. I became the youngest partner and started the entire crypto journey there. And during which I invested in Bitcoin mining, which my high school friend kind of have a data center in Mongolia, China. So I was just an investor, right? So I bought some. He helped me bought some servers, put it in his data center, and called it a day. And looking at my wallet, it's like, Bitcoin comes in, it's great. So that thing lasted like 2 years and such. Basically, laissez-faire, I'm not doing much. But unfortunately, Xi from China wasn't so fond of Bitcoin all that much, so he kind of shut that down under one day. Now thinking, the whole tariff, at least Trump gave us 90 days. China gave us 1 day. It wasn't even noticed. I saw it on 朋友圈, which is the kind of the Facebook of China. I literally saw on your social media. I was like, oh, your Bitcoin mine is shutting down today. Effectively, I checked my wallet. It's like, it's going to zero. All right, great. So I was like, okay, I either write down my investments or I can find somewhere else. Find a new home. So obviously chose the latter. And so I flew to US, one-way ticket to New York. Didn't have much connections aside from, I just spent 4 years in college there. So I was like, okay, how hard could it be, right? Just finding new data center, putting servers over. But about 80% of the capacity was coming from China at the time. Everyone was flying out. Everyone went to like, this is pre-war, right? So everyone goes to like Ukraine, Russia, Kazakhstan, like somewhere in weird the Southeast Asia countries, and obviously US, Canada is huge. And so no one has capacity and no one wants to talk to a amateur Bitcoin miner because my scale is too small. And so I did another thing, which is like, okay, how hard could it be? Right? So I decided to build it myself. It was a stressful kind of 6 months to a year process. I scoured the earth. I looked at Google Maps every single day, pick up my phone call, my phone book and start dialing, looking for a local chamber of commerce. And my line would be, hey, my name is Alex. I want to buy power. I want to buy land. I want to build a data center. So that thing, so fast forward to 2024, I was able to build 3 data centers across America, in Arkansas and Texas. And even though we pivoted to the cloud space, which I'll get to, currently we're still the largest Bitcoin miner of Arkansas, right, before I pivot. And because I'm in Silicon Valley, and about a year ago, a lot of founder friends and my VCs that backed me, that supported me, say, hey, Alex, my portfolio company, or founders friends, like, hey, I'm doing AI training and I need some GPUs. You must have a lot of GPUs because you do Bitcoin mining. And it just happens I do. So that's where kind of the pivots begin. And initially, it was just getting people GPUs access, right? And then it kind of evolved into something that's more profound and complicated, right? People don't just need the GPUs access, but also the entire ML stack, and now going into kind of the API access, so that people don't even want to interact with GPUs anymore. They just want to have a simple API for them to play with. So that's kind of the whole journey of how I started in mining and then pivot to cloud till today.
So your team describes you guys as, we are the Shopify of AI. So yeah, I love that tagline. So can you tell us a little bit about the company, the problem you are solving, and what you think the opportunity is?
Yeah, that's right. I think there's a new term, right, called neoclouds. Basically, these new suites of cloud service provider that's not the GCP of the world. And everyone tries to be the new AI AWS, right? But we're going on in a very different path. First of all, I think I've never heard of anyone say, hey, my cloud bill is actually pretty low, right? Never, no CTO would tell you that. And people are always complaining that, they're taking advantage of kind of storage or compute costs way too high and they aren't able to move. So the whole Shopify idea is basically moving the DC, moving the cloud stack on edge to their local edge, right? So they'll have the same cloud experience without moving their data over, which saves a lot of efforts and time for larger businesses and enterprise that already have these kind of cloud relationships. So that's where kind of the Shopify AI comes from. And if I may go into a little bit deeper, is we structure our cloud into kind of 3 building blocks. One is the GPU hardware. We don't have to discuss too much of that. We're a top 10 NVIDIA cloud partner, so we buy their NVIDIA GPUs and we design in the same way as kind of the reference architecture designed by NVIDIA, right? So it works. The second stack is called the cluster engine, right? Think of it as the operating system, the Windows or the hypervisor layer of GPUs. It manages, controls of the GPUs, provisions, everything, right? And on top of that is the inference engine, which is the API model as a service layer, where people will be able to not interact with GPUs directly, but they will just be picking the models that they want to use and start building applications. Or they already have their own fine-tuned or prompt-trained models over and host it on our models, and we can sell them in an API format, right? So they can bring their own model, or we can provide models that we built that's highly optimized, it's distilled, whatnot, And so those are kind of the three building blocks. And reason why I say it's Shopify AI is because people can choose which blocks they want. So they can buy these three things in combination. They can, if they want cloud experience, they can host in our data center. That's fine, right? But if the enterprise say, I already have GPUs, just give me the cluster engine, which happens a lot, then we license that piece, right? And if they want both the cluster engine and the inference engine, we can also do that, right? Or if they have both the cluster engine, I have my own orchestrator, I have my own GPUs, but hey, I want your model library, right? I want all these model oasis, model library to play with. We can license that, which is a container, right? So we can move that over. So it makes it very, very seamless for anyone that wants to build AI instantly without kind of disrupting their existing data flow.
So you're doing something that's really kind of interesting, right? I mean, one, it's like you've got kind of a consumption model for consuming GPU, really, or just, I mean, you're sort of abstracting the GPU away and just saying, like, here's resources that you need to do what you're going to do, right?
That's
Which
right.
I think is really interesting. And I think, you're taking a lot of the hard part, or even the part that isn't within the core competency of most businesses to do. You're kind of stripping that away, which is really interesting. But I think, when we talked earlier, there's another aspect of this that I think is really interesting too, because so much has been focused on the amount of resources that it takes to do training, right? And there's been a lot of focus on building, clusters for training AIs, but your vision is more on the inference side, and you're seeing the bigger business really kind of emerging there. Could you talk about that a little bit?
That's right. So I have a feel of the market. This is my subjective kind of view of the world. This feels a lot like kind of the 2010 to 2014 era, where iPhone just becomes pretty decent. LTE is actually, I think we're at 4G around then, right? And it's just like you can do video streaming, you can do like these high bandwidth stuff, right? So you have like Ubers and Airbnb, these like really great apps being built. And I see that literally. If you go to Blue Bottle in Silicon Valley, everyone's talking about agent. Everyone's like building their own app, right, so to speak. So I feel the same as I currently right now. Like everything is just getting started because in the last 2 years, these really top companies have spent billions of dollars doing these foundational model training, right? Literally billions of dollars. OpenAI, Anthropic, and DeepSeek, and QN, all these like Magnificent Seven, right? And also the Chinese shops, open sourcing a lot of things. And now the models are just good enough so that people are like, oh wow, this is actually pretty good, and they're open source, right? So they can start building different applications themselves, and you no longer need a platform level or infrastructure level person, right? Because you need to provision all the GPUs. They're actually quite difficult, and so not many people have that capabilities, right? You have to have a team. You have to form some sort of company in order to do that. So that means like you need to raise like $5 to $10 million in order to do something like that. But now it's literally like a college grad. You'll be able to use, I have an idea, I can pull an API and start building cool apps. And the coding part, you can outsource that to like Windsurf or Cursor. So it just makes the entire development process so simple and so fast. And so that I just see a lot of proliferation of different products, different being built. It doesn't have to be like a genius idea. It just be a very simple kind of search query of a specific kind.
Yeah.
Right. One is like literally someone just upload a Bible, right, and then start charging church like $10 a month. It's like AI Jesus. So it's just like a very simple idea, and you will be able to monetize, right? Selling to the influencers, some sort of search query on all the competitors or things like that, right? Like AI has been pretty good at doing these type of things, and people are just building different models right now. Mm-hmm.
So the interesting thing about that is, like, if you look at like some of the big seven you kind of mentioned there, and what we're seeing is like there's just massive infrastructure costs to sort of training these models. But at the same time, you're seeing the commodification of large language models, of foundational models, that the like the cost per token went, I think, from, like $20 to like 7 cents or something now, or even lower, right? I mean, so the economics of building there, I think, are strained. Whereas like what you're doing with, regarding to focusing a lot of like the tools that you need to like do the work with it, I think that's really where there's more upside potential at the end of the day.
100%. I mean, I think I forgot which VC or someone said it. Like, if you have a 10x reduction in cost of some kind, you will have a 100x or 1000x increase in
Consumption.
I think in consumption, right? It's like kind of the same thing, the same thesis as kind of Elon saying, hey, if we lower the cost of space travel by 10x, then there will be a lot more applications being built. Same with like planes, right? Like 50 years ago, only the rich can fly planes. Now, like literally anyone can fly on a plane and go somewhere else. It's like $100, $200. You can plan it and go places. So I'm seeing the same thing. Literally like Claude, I think is, last I checked, is like $32 per million token, and like a DeepSeek model, which is if not on par, but slightly better, it's $2, right? Some of them are even less than that. So that's literally 15x cheaper. And so when you have that, you're just like, oh, wow, I can build this now. It makes economic sense. And so there's just so many cool apps and different agents or applications just being built right in front of my eyes. And so I would categorize into kind of, AI has 3 categories, right? One is training, inferencing, and fine-tuning. Sorry, let me put it in right order. Training, fine-tuning, and inferencing. So it's this loop, right? Of you have to, it's just like models like a kid right now. So training is like you put them in schools, the K-12 education, right? They go into that course, and then and then they go into production. Production means like inferencing. So you throw them out into a real world, like, all right, you're 21, you're old enough, go survive, right? Get out there, exactly. And then they will go through some struggles, and they have to update their knowledge base, right? And so they go into that fine tuning phase, like, okay, I got more information. Let me kind of self-reflect on how to be better in this particular domain, right? So that's called fine tuning.
I like that because, when I think of the kids, they by the time they get to high school, they know absolutely everything. They just need a little fine tuning.
Yeah, exactly. To rough out a little bit of edges,
Yeah, they're a little rough around the edges.
Yeah, exactly. So right now, it's literally, I see my customers are all doing fine tuning and inferencing, with the exception of like particular domain, which are still doing training, which is like foundational gaming engine, gaming LLM, right? These type of niche domains, people are still doing training, right? And then there's all the big boys are still doing training, right? They just want to keep better because the Chinese and Americans and all the M7s are competing with each other. So they just will continue to drive new innovations on software. So models will just get a lot bigger and bigger. They'll just get better. And then people will continue to open source that, right? So it's a closed source versus open source, and they'll continue to compete, which is really amazing for everyone else. Which is like, all right, great, we got better model now. And so you don't have to think about the cost and then performance, because it will. You just have to have an assumption that it will just get better, because it will. It has been and it will.
Yeah. Well, I think, there's another aspect of this too that I think is interesting. And when you look at NVIDIA and some of the prescience that Jensen had, I think, around building GPUs was that he spent the whole company spent a lot of time on developing the software around GPUs. the tools that you need to make the GPUs go. And I think that's kind of where you're at here too, right? With the cluster engine, and you're building this hypervisor, and just and some of these inferencing tools and things like that. You're taking the hardware and kind of giving people the tools to use the hardware.
That's right.
So I mean, do you envision that as being sort of like the core of your business going forward, building more tools and just like kind of further abstracting that piece?
Yeah. Okay. Yeah. So here's how I think of the world that's happening. Model shop will continue to compete. I think this is like a ground truth. Okay. Model shop will continue to compete. Tokens are going to be cheaper, and then models are going to be better. So that's one ground truth. Another ground truth is all the hardware companies will continue to compete, and NVIDIA will continue to compete with itself, and they come up with with 2x or 3x better GPUs every single year. And AMD and other kind of specialty chips are kind of compete. So they're competing at the hardware level. Model shops are competing at the software level. And what we are doing is we are competing in the system level. So we put these two together, right? This inference engine is about, right? We put it models and put it on our GPUs. So we integrate on the system level. Sometimes we go below CUDA level, so very infrastructure-y. So we make sure that per GPU, we can squeeze out the maximum amount of token for users, right? We're optimizing on the system level. So that's what we're doing. And so that's, I would say, a larger thing that we will continue to compete. We will continue to make sure on a system level, everything will be better, right? And then we are building and abstracting out different difficulties, right? Provisioning the GPUs or providing more ML frameworks and tools for people to better fine tune, right? Remember, like once you get in production, you have to update your knowledge base, so it goes back to the GPUs, and then do some minor small training. It's called fine tuning, right? Small training. Right. And so that cycles continue, but this is like when you have new data coming in, you still have to ingest it, right? You have to ETL, you have to clean it, you have to sort it, you have to label it.
Yeah.
Right? We're not providing that, but we will integrate other services like great companies like Scale and so forth, right? We want to integrate all of that to build our ecosystem so that people can easily fine tune their models, their products on our platform, and then push it out to production again, inferencing. And so we're optimizing on a system level, and then on a smaller subset of that is like we will provide better tools, better connections, inferencing, same thing, right? We'll lower latency, more global coverage, etc., etc.
You probably have, like, as your product matures, you probably are going to have like multiple tiers, I would imagine, of service that you're going to be able to deliver to people. Do you envision, like, in the future, providing like just a general like SLA based approach to this kind of consumption model?
Yeah, we do. So we offer 10 minutes, 1 hour, and 2 hours. And so we will continue to squeeze that timeline. So I'll explain what that means. 10 minutes is within 10 minutes, we will have our engineering team reach out to you if you have any questions, right? And then 1 hour means full system diagnosis, right? We will identify and tell you, okay, within an hour, here's the problem, right? And within 2 hours, you should expect full system recovery, right? So these are general SLA that blankets all our customers. That's a requirement on our end. And then there will be kind of minor different product lines that people need, right? The big LLM shops, they know everything and have a lot of resources. They have infrastructure engineers, they have platform engineers, they also have application engineers, they have model engineers and researchers, right? So we give them kind of the full control, full access of open ports, different ports, and firewalls control, router control, all of that, right? And then some other suites maybe kind of just some student groups, like some like founders, like early stage founders that want to build stuff, they just want a container. And we can also offer that. We abstract out a lot of the infrastructure sources so that they can have the best experience without kind of being scared of like, well, there's a lot of things that I do, but don't know what to. So we have starting to bifurcate into different product suites, but they'll all be blanketed by kind of the 10 minutes, 1 hour, 2 hour.
Since you're abstracting so much of this away, are you provide? I mean, it sounds like you can provide everything from like almost bare metal to further up the stack and give tweakability along that in different capacities. Are you doing a lot of virtual GPU stuff as well, or like where you're slicing them up even into finer increments?
That's right. So we offer two major kind of service. One is bare metal and different level of bare metal. If you want full access, we can give you full access. We can also offer you containers, right? So you can have a blanket compute resources, and then you can open and close different containers. Maybe you want to do fine tuning here, do training here, and inferencing there. You can open and close, right? So those are different things that we offer. We slice GPUs, and we're it's on our roadmap to integrate with Run AI, which is a company that NVIDIA acquired, and they open sourced it, which is they're very good at parsing kind of memory of GPUs. So that will be on our roadmap to kind of do that. So we will continue to integrate and innovate on a system level to make these things happen.
What do the economics of building these facilities look like? Because Xi chased you out of China because he didn't like the way the power consumption was going around Bitcoin, right? And so like now everybody takes these to different places. I mean, obviously this is we literally are having conversations about renewing the nuclear power industry, at a very rapid pace to sort of supply power here. Like how do you figure out where to put your data centers, where to get that power?
So it's a very interesting question. I like talking about power because actually is a bottleneck right now for America and for a large part of the world. So we don't operate in China, so we don't know like what's happening there. I heard that they're very, very fast, but in the places where we operate, we're in Japan, in Taiwan, in Thailand, in Singapore, and in the US, right? And having built mining, kind of understand how US operates. So long story short, to build a data center, you need three things. One is power, fiber, as well as just internet, right? And water. These three things. And those are very, very crucial. And people talk about and emphasize about power, but also fiber is also important in terms of the lead time. So US surprisingly doesn't lack power generation, because US is, I think, 70% nat gas, right? Natural gas power. So the cool thing about nat gas is literally you order a turbine and you can pump nat gas in, and there's boom, 300 megawatts increase overnight, right? Nuclear is a little bit more difficult, but technically you can generate power very, very fast. But you need these three things together, right? And these power facilities are typically in a very remote places. So you want to pull, again, right? These are not kind of your phone. You can survive with 100 megabytes per second. These data center requires redundancy of fiber cables pulling from the central hub. So you need like at least 100 gigs of dual line fibers. So just in case one somehow gets snapped, then you have another redundant. So also water is for cooling, right? And so you need to have all these three together. So what US lacks is actually distribution of power, not generation of power. And distribution is actually, again, bottlenecked by regulations. And these power companies are just a bit legacy businesses. So they move slower than the data centers and AI guys require. AI guys is like, we want it tomorrow, we want it next month. And power companies, like, the best I can do is 2 years, So
well, the lead time on transformers can be really long, right? So
yes. So that's kind of the economics on the power side and data center.
Yeah, I mean, it's like that old saying, the future's already here. It's just unevenly distributed.
Yeah. Yes. Actually, yes. Yeah, I like that.
So Alex, obviously you're in a huge market. So I have to think you don't have your customer base, your ideal customer base can't be huge, I would think. So who is your ideal customer?
My ideal customers are these AI native companies that want to scale, right? That wants to fine tune, that wants to train, that wants to inference. That would be my ideal customers, right? So they have the knowledge base of what they need to do. They just need someone to provide really good infrastructure. And what we provide, what we're really good at is system level optimization. So if I may go into kind of the technical details a little bit. So right now, all the models are going into the multimodal world, right? Or mixture of expert, right? So meaning that the latest Llama 4, right? They have 120 experts. What that means is like, if you ask the LLM a very detailed like question, like how do you compare kind of US China conflicts, things like that, like it's kind of complicated detail. So it requires kind of the long term, like long compute time thinking, right? Same with humans, like, oh, let me get back to you in an hour, let me do some thinking, right? So you want to pull the largest model possible, right? The smartest model possible, right? But if you like, what is the color of AirPods, right? It should be quick thinking. You don't want to interact with this long-term big model, right? You want to interact with the smallest possible model, which is like quick and give you an answer. That's called mixture of expert, right? You have different experts. And so right now, the current thing is you're putting all these, consolidating one model in one GPUs or one server. And so you're running the process physically on the same hardware. So that makes things very, very slow. And so you would probably think like, okay, we should put it in different GPUs, right? And so you essentially kind of delegate out all the difficult tasks to different people, right? For these deep research, you probably will, same with people, right? If you ask these like deep research problems, you want to ask probably like poli-science PhD at Stanford, whatever, right? And he would give you an answer, right? If you ask like, what is this color? Literally anyone you grab on the street is like, what color is this, right? So you want to delegate these tasks out. Same thing as what we're doing. It's the system level. We delegate tasks out to different GPUs and optimizes that, right? So I think that's things that what we do on the compute side, like during transit, meaning it's compute, and as also at storage, which is kind of when things are set, we put it in different locations so that it's distributed for optimized performance.
I think in the early days of LLMs, people weren't realizing, that they were sort of surprised by the fact that statistical models of the English language couldn't do math, for example, and that, these simple things needed to be added in around the edges to sort of complete that picture, right? So that's we have come a long way in a very short amount of time, which is really, really interesting.
So right now, if you just want an API, literally go on a website and you can choose your own poison, choose your own model, and you can start playing with it. Like right now, you don't need to talk to anyone. Another way would be talking to sales. If you're a startup and you're scaling fast and you need people to kind of more bespoke services, then we can also offer that and give you kind of the GPU resources. I'll give you an example. Like we have a customer, and because we have data centers globally, so we're able to scale quite broadly. Because everyone's building apps, right? You don't know where a customer's coming from. You kind of know. You're like, oh, some people are pinging from like East Coast, West Coast, as well as somewhere in Asia, maybe in Japan or Taiwan, wherever. And it's like telecom. You need coverage, right? So it's the same thing that we offer these type of things. So one example is we have a startup customer. In the first month, it scaled 8x in their month, and the second month to 11x. and we were able to perfectly match the customer growth curve and give them the right amount of resources for them, right? So this is the first phase. I think next couple of months we're gonna roll out auto scaling, so it will be able to detect automatically and scale accordingly for the customers, and then also provide the lowest ping possible, right? So if the customer is coming from Japan, then we will be able to ping the Japan data center and provide resource for them.
So from a competitive perspective, how do you guys win? Like, what is the, couple things that you can kind of point out that you feel you have an edge on your competition, and, and feel comfortable to, speak as freely as you'd like, because I think this is a really interesting conversation to hear about. How do you guys differentiate?
And let me add one more thing to that. Like, who do you view as your competition? Is it the AWSs of the world, or is it, other neo clouds?
I think it will be the other neo clouds would be my competitor. So I would say two things: is we're the only U.S. company, and I kind of fact checked this with NVIDIA. It's like, is there anyone operating in Asia? Not that I know of. So so we're the only neo clouds that have robust data centers directly operating these direct data center directly in Asia, right? So if you're building a consumer app, right, and you have customers globally, we will be able to service you. We're probably the only US shop that can help you with it, right? Again, right, it's literally from East Asia to Southeast Asia and US East and US West, and so we basically have the entire coverage, and we're expanding to Europe. So that's one thing. So global coverage. Second thing is the whole system integration. So what I talked about, kind of partitioning, desegregating different experts as well as compute, is a very novel thing that's just happening right now. And so to my knowledge, none of the shops, neo clouds alike, have these capabilities. Everyone's just storing in, they're shoving them in one server at this moment. And so you basically get a bang for your bucks, right? Like, you're renting the same GPUs, but my output is 70% more than other shops. And so even though our price point is slightly more expensive, like 20-30%, right? But your total output is just much more. Everyone's GPU is like pushing 10 million tokens per minute, something like that. And I'm pushing like 17 million, right? And so you're saving a lot more money because we do very deep hardware and software integration. The cool thing is we were able to replicate what DeepSeek was able to do. They basically, the reason why they broke the news, right, is because they went below CUDA, right, able to control partitioning kind of their models. I think there was news that came out a while back. It was like their cost is like 10x lower than anyone, but they have 500% profit. And how do they do that, right? It's because they do very low level integration. And I think this is the biggest thing of the AI native cloud and traditional hyperscaler clouds, right? Hyperscaler clouds are basically abstracting resources, right? Their traditional way of doing things, abstracting resources, is basically all the CPU, GPU, storage, networking, these four things. Abstract out, you build applications. That's all the hyperscalers are building exact same way. And the AI native clouds, at least we are building a truly vertical cloud, right? Is we integrate the software and the hardware to make sure that it functions as a whole. That's why, just iOS is just better than like Windows in terms of user interactions, speed and responsiveness, right? It's because Apple owns the hardware, right? They designed the hardware that makes things more efficient. So we're designing the same in the same method, is the hardware and software integration. And so I would say these two things would be our advantage. One is our global reach, and second is our kind of tech capabilities and flexibility and speed.
And I got to think that, the pace of innovation in the world of AI has been so incredibly fast that there's been a tremendous amount of optimization that's just not happened or been missed. And like the fact that you're focusing on doing that optimization, I got to imagine there's just a lot of gold there, right?
Yeah, I think future of GMI again with what the name means, right? It's general machine intelligence. We want to build Asia future with people, right? We're enabler. We want to be your painkiller for all the AI troubles that you have, right? So the founders and enterprise can just focus on building really amazing applications. I think the most exciting thing about building GMI is just see so many amazing startups and ideas being formed, being built, and that really excites me. So we want to be kind of the Robin of AI, where our customers can be the Batman and building these shiny applications in front and public, right? So I think that's a really really cool thing. And so we just want to focus on being an infrastructure provider to support making sure that your apps, your agents run smoothly, making sure that your AI models is trained as you want it, and providing the best and easiest access to resources and abstract resources if that's what our customer needs. So that's kind of how I see the GMI going forward. And we'll continue to optimize on the system level to ensure that our customers will have the best experience.
And where can customers find you? GMICloud.ai, or what's the best?
That's right, GMI Cloud.ai. And if they want to find me, I'm on LinkedIn, and people can reach out to me.
Awesome.
Great.
It's exciting to see what you're building. Congratulations on your success to date, and can't wait to see where you go from here.
Absolutely.
Hey, Chris, how hard could it be?
Yeah.
How hard could it be?
How hard could it
Right?
be? You know?
Well, I think you're finding out how hard it can be.
Yeah, pretty difficult every day, but able to persist. I think persistent is number one.
But at least you're doing it so that you're doing the hard stuff so that other people don't have to. And that's the important part, right?
Yeah. Hey, you know, I bought land from my
That's
old,
right.
cowboy
Yeah.
in Texas and Arkansas, you know? After that, I think everything is a little bit more smooth sailing. So
Awesome. Well, we're definitely gonna keep watching you guys, and we really appreciate the partnership here and collaboration. You are awesome to talk to, and I hope you come back to the show.
absolutely. And feel free to reach out and happy to grab a beer, coffee, and we can just talk about like different cool applications because I'm again I'm the only U.S. company that have real insights into how Asia is developing AI. Right? I listen to like Golden Pod and things like that. They just like talk about China and talk about Asia. I'm like, I really want to go on a show and just talk about kind of my view, and this is like real happening. And I just have a lot of things I want to talk about, especially me coming from a Taiwanese guy, kind of sitting and squeezed between both worlds, right? And then seeing how Japan is developing their own stuff, how Singapore is developing, and how US is developing, and see everyone's kind of view of the world colliding, and different technology, different trends, and what's hot. Because I can read out all the BS that VC is talking about. It's like, oh man, they're growing very fast, but actually I see it on my GPUs. Are you growing fast, or are you just raising without not doing much, right? And so there's a bunch of different markets, and so we can talk about this. Like I'm pretty sure for hours about cool stuff or power or anything.
Yeah, on the next podcast. Hey, I think that's the cool thing, right? AI is the gift that keeps on giving, and we are just getting started.
Literally just started. This is 2010. Like everyone's building app. We haven't seen these like major killer apps yet. Like these $1 billion kind of revenue. Yeah.
But like 2 years is like 100 years in AI years, I feel like.
Yes. AI works in 7 days increments. Within 7 days, there will be some shop open sourcing some new thing, or open AI come up with new models, new applications, new products, found product market fit, scaling to 100 million. Like literally every 7 days, there will be a major news come out from a shop in the AI world.
I think we've just replaced Moore's law with Yeh's law of 7 days.
You heard it here.
You heard it here.
You
This
heard
is
it
where
here,
it started.
listeners. This is where it
Every
was.
7 days.
Every 7
Well, thanks
days.
so much for being on. Really appreciate it.
Yeah, Alex. Yeah,
Absolutely.
Thank you so much, and we look forward to the next one. Take care.
Thank you, Chris. Thank you, Sandesh.
Well, that's the show. But before you roll, sales pitch warning. We're building more than a brand here. We're building a community. So your support means everything to us. So please like, comment, subscribe, follow, and also reach out to us directly. We want to hear from you. Thank you so much for your support. Until next time.